So far, we've been exposed to the regular type of classes where we instantiate an object, then access the methods and the properties and utilize them throughout this object. But we have different class types, such as sealed or static or abstract, and each one of them used for different purpose. They exist really to enforce specific behavior or to improve code organization and support different design patterns. In this lesson, we are going to exhibit the sealed, static, and abstract classes, and we're going to discuss all of them and see how and where to use them in our application. Okay, I'll begin with a static class, and I'll just create a class called math utility. And this class is going to be of type public, and then I'm going to use static. And the static class is called also the utility class. It cannot be instantiated, and it should be used directly using the name of the class and then the name of the method. Let's create one of the methods, and let's call it add, and it will return an integer. I'm just going to use the Pascal case in here. I'm going to take two numbers, a and integer b, and then return a plus b. There's another way really to write any methods in any of the classes, not just the static class, which is, if it was a simple method like this, we call it an expression bodied method, which is like this, and then a plus b. And we call this the lambda expression, and this will return a plus b. So it's equivalent to the former one. It's equivalent to the one that has the body and then return a plus b. So now if we try to access this class using math utility and create an object out of this class, let's assume math utility equals new math utility. Okay, now this will tell me that you cannot declare a variable of static type math utility because it cannot be instantiated. And instead of that, if I want to use the method inside that class, math utility dot add directly, and then pass in 4 and 5, okay, and I can save them inside a variable called add addition anything, and then print out the variable f5 will print out 9. Now why do we use this? We use it to enforce a pattern. For example, if I want to preserve this class from being copied or inherited or instantiated, then I just use this class. Because the static classes cannot be instantiated or inherited, they have to be used directly. Let's see if I have also a property. Let's assume that this property is called number 1, for example, and I'm going to use number 1 in here. Number 1. Okay, now hover your mouse over number 1, this one. As you can see, now math utility dot number 1 cannot be declared instance member in a static class, so you cannot declare properties. Now let's see the abstract class, and it acts like a blueprint for derived classes. It allows both the implemented and unimplemented methods. Let's create a class, and let's call this class shape, and inside this class I'm gonna declare a method, but before that I'm just going to give it an abstract to make it an abstract class. Then I'm just going to give it a method abstract calculate, and then I'm just going to leave it unimplemented. Now if I want to derive a class from this class, let's assume create a class called rectangle. And this rectangle is public as well, and it inherits from shape. Now look at this squiggly line. If you hover your mouse over it, it says rectangle does not implement the inherited abstract member. And if you click Control and dot, you'll see implement abstract class, and it will provide you with a method. Now I'm just going to delete this one, but notice here there's an override, and there's double, and there's calculate. And since I'm not passing anything really, you can pass still. You can pass things in here. You can pass, for example, the X and Y. It doesn't matter. Or you can just rely on your fields from here to calculate the method, since shape could be circle as well. So you can say integer Y, X and Y. Okay, and then you can say return X multiplied by Y. Or if you have multiple shapes, then you just delete them from here. And let's make it more generic, so we're not going to pass any parameters. You can pass parameters in here, by the way. You can do the properties and you can do A and B, alright, but you don't have to. We're just going to make it as generic as possible. And we're going to pass the properties in here, and since this is rectangle, then we're going to take the length as double, and the width as well. I'm just gonna stick to the camel case and camel case in here as well. Okay, and now return length multiplied by width. Okay, and it says it doesn't implement because this has been changed from an uppercase to a lowercase. Now if you defined a class called rectangle equal new rectangle, and then let's enforce these fields to be entered using a constructor. So double L, double W, this dot length equal L, this dot width equal W, and then this could be length by width. That way we enforce them. So 5, 6 classes, and there's no need for system because classes just exist inside the classes. Now it defines a rectangle, then rectangle dot calculate, and then we print out calculate as the area equals, and then print out the area in here. The area of the rectangle is area, and then it will print out the area of the rectangle. Okay, it's 30. Now what if I have another class called circle? Okay, and this class is called circle. We're gonna also inherit this class from the class shape, and we're gonna implement the method using public override double calculate, and inside calculate, first we're gonna declare two properties. One of them is called the radius. Just gonna use double. We really just need radius because then pi is known as 3.14 or approximately. So return radius multiplied by 3.14. We can also instantiate these objects, or could declare a constructor to pass in the value of radius. So this dot radius equal r, and then I'm gonna define another shape called circle equal new circle, and I'm gonna give it like 6.5 anything. And to calculate the area of the circle, area 2 equal circle dot calculate, and I'm just gonna copy this line, and this will be the circle, and area 2 now implement is 20.41. So we call this what I've just done right now, declaring an abstract class called shape, then implementing this class in the rectangle and circle differently. We call this polymorphism. And polymorphism means multiple shapes. It means this method is implemented differently, and I just provided the blueprint of this method in here in this class, and this will act like a guideline of the method, a signature for the method, but it doesn't have any implementation. Each class implements this method differently, and I can declare this method in any of the classes, and it will be implemented in a different way according to the class's needs, but they all refer to this method. So we call this polymorphism. Of course, you can have also implementation inside the abstract class, and they should be marked as virtual. So public virtual, and then the data type of the function, let's assume move or move. So the shape just moves, so the shape is moving. Okay. And we can also go to the rectangle, for example, and create an override of the move using public override, and then void move, and then we can make it base.move, and that will call the function. We can also implement this using the rectangle is moving forward, for instance. Okay, and then in the circle, I'm just going to copy the same thing, circle, and the circle is moving backward. Okay, and now if you implement this inside the program.cs, let's see. So rectangle equals new rectangle, and we need also to pass in the length and the width, 7 and 6. Of course, we need to change this namespace to classes. Okay, and then the circle equals new circle, and then 5.5 for the radius, and then we have rectangle dot move, and we have circle dot move. Okay, let's execute it, and now the shape is moving, first the base class, and then is moving forward for the rectangle. The shape is moving when we call the circle. The base class first is called in the circle, and then is moving backward. Now, what happens if we deleted this one? Look, now if we deleted this one, okay, and I'm also gonna delete this one from here. Okay, and now execute it. Now it just implements the method inside the derived class. the circle and the rectangle, it doesn't call the base class. So if you need the base class also to be called, you have to call it using base dot the name of the function, which is in our case base dot move, like this. Okay. And last but not least, we have the sealed class, which allows the instantiation of the object from the class itself, but it doesn't allow inheritance. Let's create a class called security, for example, and convert this to public. And now this security will be a sealed class. Inside security, I'm going to have a method called encrypt void encrypt, and it will be implemented as console.writeLine. Oh, this encrypt needs parentheses, console.writeLine. Okay, and it will say the data is encrypted. Okay. Now, if I created another class called network security, for example, I try to make network security inherit from the security class, like this, it will show me an error. And this error is called cannot derive from sealed type security. But you can instantiate it nonetheless using the class name security equals new security, and this class, the namespace is classes, so using classes. Okay, and then security dot encrypt, and that should print out the data is encrypted. That's it for the types of the classes. Of course, we have other types of the classes that we didn't cover, and they are beyond the scope of this course, like the partial classes and the nested classes as well. You can explore them yourself, but for this course, we're not going to need them. Thank you.